We all love and consume ice cream for the kind of sensation it offers. What makes ice cream appealing is its texture. A common question that is often overlooked is why do we like ice creams? This is partly because food manufacturers have mastered the techniques to provide best ice cream possible. But did you know ice creams are susceptible to defects as well? Ice cream contains a lot of components like ice, lactose, fat, and air that impart it the characteristic mouthfeel and texture. But today we'll be discussing the ones that are responsible for causing defects in ice cream. Ice and lactose, which is a reducing sugar present in milk, both have the ability to crystallize in food products like ice cream. The result of crystallization is that ice creams become grainy in texture and when eaten will give feeling similar to what is experienced when sand is in mouth. Therefore, this condition is termed as Sandiness in ice cream. Lactose is a dimer which is formed via glycosidic linkage of beta galactose with beta glucose. It can exist either in alpha polymeric form or beta polymeric form. Now, during freezing process, there are some areas in food which will not have water in its solid state, meaning water is still in its liquid state. And when you reduce the temperature further during freezing process, the water will begin to crystallize into ice. At a particular time, the concentration of lactose will be so high because you have ice crystals already crystallizing out of the system, and it is only solutes that will be present in the frozen food product. Lactose concentration, when it reaches greater than the solubility of lactose, lactose will begin to crystallize out. This manifests as sandiness in ice cream. Generally, if the crystal size is greater than 30 micrometer, is when we experience sandy mouthfeel. The optimum crystal size for a pleasant mouthfeel in ice cream is around 10 to 20 micrometer. Okay. Having said that, we have to keep in mind that small crystals can grow over a period of time by a process called as oswald ripening. So you have to always be mindful of the fact and check the temperature during storage and distribution. Another way to check lactose crystallization is to make use of appropriate stabilizers that not only prevents lactose crystallization but also ice crystallization. So how are food industries able to give us the exact mouthfeel? One of the ways crystallization is controlled during manufacture is through freezing process. By varying the time and temperature used for freezing, we can obtain the desired crystal size. Now, we can differentiate the freezing process into two depending on the time required to freeze a product. We have something called as slow freezing and we have a concept called as quick freezing. So, in slow freezing, we subject the product to a desired temperature, and this temperature is reached within a few hours to a few days. What happens in case of slow freezing is that large crystals are formed. Volume of crystals formed is lower, but since large crystals are formed extracellularly, it can interact with the neighboring cells, causing quality degradation of your food product, as these large crystals are able to penetrate to all the biological cells that are present near it. In case of quick freezing, the temperature of food is lowered to the desired final temperature, which is minus 20 degrees Celsius, within 30 minutes. And when you do so, what happens is small crystals are formed, but the volume of crystal formed is high. Nevertheless, there is improved quality because the crystals are formed intracellularly. It is formed inside the cells. That's why you say that the damage to the biological tissue around is not much. It depends on which tissues have this crystal present and in which tissue it does not have. Those tissues where there is no ice crystal formation, there is no damage. That's one of the reasons why you say that frozen products, they have much higher nutrient value than canned food products. Thank you for staying with me through the video. In my next video, I'll be discussing why milk powders often tend to cake when there are temperature fluctuations. Until then, merci beaucoup.